Alright, so we're going to wrap it up here with this video. Thanks for sticking with it. We're going to do some examples and see how we can use these formulas. So for this one, we are looking at the Math SAT test. The standard deviation for the Math SAT test is 100. The variance is 10,000. An instructor wishes to see if the variance of the 23 randomly selected students in her school is less than 1,000 or 10,000. The variance for the 23 test scores is 7,225. Is there enough evidence to support the claim that the variance of the students in her school is less than 10,000 at alpha being 0? Alpha being 0.05. Assume the scores are normally distributed. So this is really nice. It's a nice normally distributed curve. So she is asking about the variance. So we have our null hypothesis is a variance of 10,000. That's what we were given. And we want to know if the person's school is less than that, which is the claim. So we got to figure out what the critical value is. And to find the critical value, remember you're drawing your chi-squared. We see that it's a left tail here. And so here's our critical region. And we have our alpha is 0.05. However, it's the chi-square, so we need the area on the right. So let's highlight that in yellow. And the area on the right here is going to be 0.95. So you look up the area 0.95, right? And our degree of freedom, degrees of freedom equal, we got 23 minus 1, so we get 22. So if we look up that, we should be able to go here. All right, so when you look that up, you should get 12.338. So let's continue on. I'm going to continue to draw the picture here. And our critical region is over here. Okay, so then we substitute in to find our test value. This is our test value. We have our n is 23, our s squared is 7,225, our sigma squared is 10,000, and then we see our chi-square test gives us 15.895. You see 15.895 is bigger than 12.338. This is in the non-critical region. And whenever those are in the non-critical region, that means you're going to accept the null hypothesis. So that's what this picture is showing you. We're going to accept the null hypothesis, aka do not reject the null hypothesis, and then let's just really verify about the claim. So remember, the claim was the alternate hypothesis. So there's not enough evidence. Not enough evidence to support the claim. All right, one last example, and then we'll be done with our equivalent instructional activity. All right, so nicotine content. The cigarette manufacturer wishes to test the claim that the variance of the nicotine content of its cigarettes is 0.644. Nicotine content is measured in milligrams and assumed that it is normally distributed. A sample of 20 cigarettes has a standard deviations of 1 milligram at alpha equals 0.05, is there enough evidence to reject the manufacturer's claim? So here we are with our variance, our null hypothesis, and that's our claim. The alternate hypothesis is that it doesn't equal 0.644. We got to find our critical values. Remember, for our chi-squared test, we draw a skewed one. It's a two-tailed test, so we have two tails here. We have our alpha is 0.05, so this we have to split our area in two. There we are. So, and remember, the chi-square gives you the area on the right. So when you look up your area of 0.025 and your degree of freedom, which is 20 minus 1, because we had 20 samples, so that's like n minus 1, which equals your degree of freedom. That's going to give you 19. When you look that up, you get your 32.852. And then when we look up, well, what's the area in the middle here? That's our 0.95. So the area on the left, or the area on the right for this left value is 0.95 plus 0.025. So that gives us 0.975. And we have the same degree of freedom. And when you do that, you should get 8.907. So those are our two critical values. All right, so let's move on. I want to draw the picture here again. So we had our chi-square. Our left value we got was 8.907. Our right was 32.852. Here's our critical region that we shade in all the time. And then we got to figure out what our test value is. So we have n minus 1 is 19. Our sample variance is 1. Our population variance is 0.644. And our number that we get is 29.5. So we see that 29.5 is just to the right of our other value. And this is in the non-critical region. Okay, so whenever it's in the non-critical region, we're going to accept the null hypothesis. So we're going to accept the null hypothesis. In other words, do not reject the null hypothesis since the test falls into the non-critical region. All right, so remember, let's glance back to see what the claim was. The claim was the null hypothesis. And let's just be careful. There's not enough evidence to reject the manufacturer's claim. That's right, because that's what it means to not reject the null hypothesis, that the variance of the nicotine content is 0.644. So this is correct. There's not enough evidence to reject the null hypothesis. All right, thanks for listening.